Okay, a very good morning to all of you. Sharing the QR code, give your attendance, then we will start. Okay, so in yesterday's class, sorry, not yesterday, last class, I discussed with you about some rectangular to polar form, all those things, right? And we discussed even one problem also. So today we will do some more problems and we will close this chapter of module 1 because some problems are required. Okay. Okay. So give your attendance and we will start. I think everybody is done with attendance. Okay. So I'm moving to the question. Acha, wait for a second. If I could. Wait. Just a second. See, this word file is visible to you all. I hope it is visible. Visible? Is this word file?
Yes, ma'am.
Take down this problem. The arms of 5-node bridges are as follows, like this. Okay. Take down this problem, and then we will start. The arms of 5-node of a bridge are as follows. Arm AB, unknown impedance R and LY in series with a resistor R1. Arm BC, non-inductive resistor R3. And then arm CD, then you have arm DA, then you have arm DE, then you have arm EC. Okay, a big problem. So you have to calculate the resistance and inductance R1, L1 under the balance condition where small r1 and r is given to you and AC supply is connected between A and C. Okay, so you could understand from this picture what is A. This is the A, this is the B, this is the C. Okay, this is the D point and this is the E point. So I think all the terminals are clear to you. Kindly draw the picture also, because that you will require. Now this is somehow Anderson bridge. Okay, see, it's not required that in all problems they will say you this is Anderson, this is sharing. Sometimes you also have to understand with the problem, seeing the problem and the circuit diagram, that what could be it, the bridge. Okay, so see, in this problem also same thing happened. They haven't mentioned here. I'm telling you it's Anderson bridge. Okay, so it's not required they will mention every time. No, they will not. So you have to yourself understand reading the question that what kind of bridge it can be. Okay, so here I'm telling you it's an Anderson bridge. So every time they will not disclose this thing. Okay, you have to draw the circuit from this particular given problem, and then you have to understand. Okay, so if it's Anderson bridge, now in Anderson bridge, so what you have to do, see in the given question, you have to find out R1. You are provided with many values. What are given? You are given R2, you are given R3, you are given R4. You also know small r1, right? And for inductance, you know the capacitance, you know the many things you know. Okay, so let us start with the problem. So problem is very small. Let me do it here only. So if you, okay, first, as is the Anderson bridge, I told you, so you need to find the resistance R1, right? From this particular problem. So what is R1 I can write? Can you tell me the formula for R1 I can write from this question? Where is R1? R1 is someone here in this circuit. This is R1. So can you tell me what is the formula I can write for R1? Just write.
R2 into R3 by R4 minus small r1.
Yes, very good. R2 by R3 by R4 minus small r1. Very good. So all the values you know, it's already given in the problem provided. So what is my R2? I can see my R2 is 250. Okay. My R3 is somehow 100. and my R4 is somehow 200, isn't it? My R4 is 200, yes. And my R1 minus R1, that is somehow 43.1. Okay, so kindly do the calculation and tell me the answer. Do the calculation. Tell me.
R1 equals to 81.9 ohm.
Yes, 81.9 ohm, exactly. So from this question, we were about to find out R1, so we did it. Okay, our resistance we have found. Now we need to find out L1. Now for L1, can anyone try for the equation? What equation can you find out for L1? Just give it a try. What equation can you write for L1? If anyone, otherwise I'm there to tell you. See, for L1 equation, you have to also take the capacitor C. Okay, that is the for Anderson, you know. So you have to take the, so the equation is a bit complicated. So it will be first of all CR3 by R4. Okay, in bracket you have to take, where is the small r situated? Small r is lying. Small r, this is the small r, the variable resistance. Okay, and it is given, the small r is also given 229.7 ohm. See, in the question is given. So here you will take small r, then you have to take R4 plus R2. Okay, then you have to take plus R2, R4. Okay, so this will be the equation for inductance. Now you tell me all the values you know. Our capacitance is 1 microfarad. So it will be 1 multiplied by 10 to the power minus 6. Okay, multiply. What is my R3? Tell me, it's 100. And what is my R4? It's 200. Okay, and in bracket you will write my R is 229.7, and my R4 is somehow 200. Okay, 200. My R2 is 250. Okay, and my R2 is again 250. You write here, multiply by R4. R4 is 200. So kindly do the calculation and tell me the answer, please. It will be somehow in Henry. Okay, something Henry will come.
0.076.
Yes, very good, Ayushi. 0.076 Henry will be the answer. Okay, see, in your exam time, you will not be having the time to derive what is L1, what is R1. So from the, it needs a lot of practice. From the problem itself, from the circuit itself, you have to understand, or you have to keep in your mind what can be the equation for the unknown resistance and unknown inductance. Okay, it's not possible during exam time to derive everything. Okay, so it's better, it needs a lot of practice. So problems I'm telling you in the class, do practice this kind of problems. Okay, then it will help you out. Either you practice these problems. So I hope you have taken down the circuit diagram also. That is important. Okay. So I think everybody has done this. Okay. We can move into some other problem. Wait, what problem? Let me see. I have. Okay, another problem is here. So I'm erasing everything. Okay, of this question. Clear? Everybody has done now. I'm erasing, clearing everything. Okay. Now look into this question. I think this is visible. Wait. Just a second. This question, you take down 4 arms. This one, this question. Okay, take it. Take down the question. 4 arm of a bridge, and you can see the bridge I have drawn here for you. ABDC, sometimes it may be in the problem the bridge is not provided. Okay, so you have to draw the bridge according to the statement of the problem. That can be also a challenge. Okay, so every time circuit will be given, it's not like that. So see here what they have asked you. Arm AB is given, okay, and arm BC is given. I mean, first of all, in this particular figure, you have to draw. I have drawn it for you, but Kaneko, you have to draw this so that they have, you know, explained here that how you will draw the arm AB. I mean, what are the components of arm AB? What are the components of arm BC? What are the components of arm DA? Okay, these are given only when you have to draw the circuit. Clear? Now, other values are given in the down, supply of 450 hertz. So this will be 450 hertz. Supply of 450 hertz is given, terminal A and C. And then detector is connected between D and D. This is the D, obviously. This is A. This is B. This is C. Clear? Now you are given R2, R3, R4, C2, R2. Okay, and calculate the C1 and R1 and also dissipating factor for this capacitor. So see where are the values situated, you need to find out, and where are the values situated that are given. So this is C1, R1, this is R3, this is R4. So this is C2, this is R2, and this is capital R2. Okay, so this is clear. So now the bridge which is shown here in this figure, first of all, your work will be to find out the balance equation, right? So I'm writing here. Okay, balance equation. So tell me, what is the balance equation? You can write, what is the balancing formula? Tell me the formula first. What is the balancing formula?
Z1, Z4 equals to Z2, Z3.
Yes, very good. Z1, Z4 is equal to Z2, Z3. So this is the basic general formula you need throughout, okay, throughout this chapter while solving the problem. So what we can write for Z1? Z1 means this one impedance. Okay, this is the Z1. So Z1 is having two components, C1 and R1. Clear? Look into the diagram. So what I can write for Z1? Can anyone tell me? For Z1, what I can write?
R1 plus small R1 plus 1 1 by j omega C1.
Yes, very good. So it will be small R1. See, we have two components only for this impedance Z1. Okay, R1, small R1 and C1. Okay, so I am just writing like this, that R1 plus R1 plus 1 by j omega C1. For Z4, I have only R4, so there is no meaning of any complicacy. I will just put R4 here. Okay, now come to Z2. For Z2, what can I write? For Z2, tell me what will be the equation. Somebody else, not Pooja. Pooja is telling me for a long time. It's not like that, no? Others are not getting, only Pooja is understanding. Somebody else will come up. Manorama, Astha, tell me the answer for Z2. And who else are there? Neha, Monica. Monica to attend my class. She knows. Monica, tell me the answer for Z2. Tell me the value for Z2, Monica. Yeah, Josna. Any one of you. Yes, Monica, tell me.
Capital R2 plus small R2 plus
Capital R2 plus small R2,
plus-
then
plus 1 by j omega C2.
very good, very good. Plus 1 by j omega C2. Very good. Okay, thank you so much. And then we will get the R3. Okay, so this is my formulas. Now you see, from this given this balance equation, you have to analyze what are the values given to you, okay, in the problem. So first of all, what we need to do, we need to equate the imaginary and real parts. So let us do that. equating the real part. So after equating the real part, what will I get? Can you tell me what will I get? I can see R1 that will be equal to this R2 plus small r2, okay? And R3 by R4. This much, if I make it wrong, then tell me. So this will be R1, R4 equal to R1, sorry, R2 plus small r2, R3. Clear? So I need R1, right? My question I need, see the question. In the question you have asked for small r1. So I need small r1. So r1 equals to r2 plus small r2. Then in bracket you keep it, and here you write it r3 by r4. So you know all the values, right? Put the values, tell me the answer. R2 is 4.8. Small r2 is 0.4. Okay. And this you have to, sorry, this will be plus. I make it wrong. This will be plus. Okay, R2 plus R4. And R3 is, I think it's 2000. Okay, and R4 is what? R4 is 4. Wait. Yeah, R4 is 2850. Now you tell me the answer of R1. Something ohm it will come, definitely. Okay, something ohm it will come. So tell me the answer. Ehtisam, be ready for the next problem. Okay, tell me the answer for R1. Do the calculation, please.
7.41 ohm.
Okay, 7.41. No. Some mistake you have done. 0.4 plus 4.8 multiplied by 2000 upon 2850. ठीक से करो. Something around.
Oh, sorry.
Tell me the answer. Josna, tell me the answer. It's a normal calculation.
3.64.
Yes, tell me. Tell me the
3.64, ma'am.
Okay, 3.64. Okay. Ohm. Clear? This is done. Equating the real part. Now we will equate the imaginary part. Okay. What is the imaginary part here? 1 by j omega c1, 1 by j omega c2. Okay. R4 by R3 I have also taken. So let us take it. So imaginary part we have to take, I can see R4 by j omega c1 is equals to R3 by j omega c2. Clear? Or you can write, what you can write? This 2 will cut out, j omega. What I can see is C1 I can write, C2 is equals to R4 by R3. Okay, so you can put the values. You know what is C2? C2 is 0.5 into 10 to the power minus 6. Okay, this has to be multiplied with R4, that is 2850 divided by R3. My R3 is somehow 2000. Okay, so tell me the answer. What will be? It is in farad. Okay, so you have to find out the value in microfarad. So
0.7125.
okay, correct. 0.712 microfarad. Correct. Now see the last portion of my sum. Also dissipating factor for this capacitor. So what is the dissipating factor formula? Do you remember? I'm writing here. Okay. Dissipating factor. So can you tell me the dissipating factor equation? If I write it, tell me the equation. What can I write? See, one thing you keep in your mind, it has to be a combination of C1 and R1. That means which you are required to find out. You have find out this R1. Okay, you have found out this C1. So dissipating factor will be such that it should be a combination of this C1 and R1 and with another term. Okay, so what is that another term that you tell me? So tell me the proper equation of dissipating factor first. What's that? Will you be able to tell me? What is given in the problem? See, your frequency is given now, 450 hertz. Dekho, supply is given. We haven't yet used the supply also. So the formula will somehow omega C1 R1. Clear? Done. So what is omega? Omega, what can I write? 2 pi f C1 R1. So 2 pi. My F, you know, F is 450. It's in hertz, as I told you. What is my C1? 0.712. Okay. Multiplied by 10 to the power minus 6. Multiplied by, what is my small r1? 3.64. Okay. Now tell me the answer.
Ma'am, 7,319.34.
Are you sure? Do the calculation properly. It will somehow, I have also converting into farad, na? 10 to the power minus 6, I have multiplied. So tell me the properly, the actuals. Yeah. It will be something 0.00, some values will be there. Okay. So do the calculation properly.
Ma'am, 0.0071.
Yes, yes. 0.007. What you told? 0.007?
31934.
Okay, 319. So I will take it somehow 32. 32. This much. The dissipating factor has no unit. Mind it. Dissipating factor is unitless. Okay. So there is a factor. So this is my answer. This is my answer. So dissipating factor has no unit. These are important sums. Okay. Okay, now we can move to another problem. Let me see. Okay, this problem is done, so I can erase everything. Okay, next problem. Let me see. Okay, this problem have you done? A Maxwell capacitance bridge. See this problem, not this one. This one problem. Wait, let me take it down. This problem have you done? A Maxwell capacitance bridge showing in the figure. See and tell me, because in the beginning I have told you some of the problem. If it's done, then leave it. We can do some other problem on sharing bridge. Okay. Leave it. We will do some other thing. Take it down, a problem, a big problem on sharing bridge. Okay, I have to write that problem for you because that problem is not in my sheet. Okay. Take down the question. A sheet of bakelite that is 4.5 millimeter thick is tested at 50 hertz between electrodes that is 0.12 in diameter. Okay. Then you see the sharing bridge. The sharing bridge. So if you remember the sharing bridge diagram that you need to do, the sharing bridge employs a standard air capacitor C2 of 106 microfarad. Okay, capacitance. Clear? Next, a non-reactive resistance R4, non-reactive resistance R4, that is somehow you can take 1000 by pi in parallel with a variable capacitor. Okay. Capacitor that will be C4. Clear? And the non-reactive variable resistance R3. And non-reactive variable resistance R3. Okay. Balance is obtained with you take down with C4 0.5 microfarad. Take it down, okay, this problem, and we may continue in the next class also. That is why I'm telling you. 260 ohm, R3 260 ohm. Calculate the capacitance. Power factor. And relative permittivity of sheet. Okay. So these are the things why you have to find out. Now first will be a work to draw the picture of sharing bridge. Then we can proceed. So draw it on your own. I mean, the drawing which I have showed you when I was teaching you sharing bridge, only that drawing will do. Okay. Where you will see C1 and small R1 that represents the capacitance and series resistance of the capacitor. Okay. So if you have that diagram, then do it. Try to understand the problem first. Tell me how you will proceed this problem. Normal sharing bridge you have to draw and tell me how you will proceed in this problem.
First we will find the value of R1 and C1.
Yes, but first, have you drawn the circuit? That is important, right? See the circuit, how you will take down the circuit that I'm drawing for you. Okay, first of all, this side you will take a C1 and this side you will be having a R1. Okay, here you will having R3 and this kind of, so how many minutes are left? 4 minutes are left. Okay, then you have to take a C2 like this. Okay, and at this portion again, a capacitor will be there. So somehow here, draw the diagram fast, okay? So first is the diagram. This is C1, this is R1, this is C2, and this is R3. This is obviously C4, which is variable. So you will have to put an arrow. And in parallel to this, you have to draw a resistance, that is somehow R4. Okay, and here they will be having a supply. That supply will get a connection like this. Okay, so this is the picture. So through which what current are flowing? Through this I1 is flowing. Through this definitely I1 will be flowing. So this is A point, this is B point, this is C point, this is D point. Through this I2 is flowing. Okay, and through here also I2 is flowing. So this is my basic picture. And if you are call about, this is IC is flowing through here. Okay, and what else? Okay, this is all about the picture done. The circuit is done. Okay. Now what else you have to do? Do the circuit properly. Then we can proceed. So how you will find out R1? I can give you a hint just before ending of this class. Small R1, very small R1 situated, it is somewhere here. See, somewhere here. So R1, what the formula I can write for R1? This is sharing bridge. Don't forget. This is sharing bridge. All the equations are not similar in bridges. So keep it in your mind. So R1, I think I can write for C4 by C2 multiplied by R3. See if I can write like this. If I am correct, then you tell me in the next class. Again, for C1, you have to write a formula. What is I can write for C1? It will be somehow R4 by R3 multiplied by C2. In my next class, you will tell me that how can I write like this from the sharing bridge. So this two formula is important. You know other values. You will tell me the answer of R1 and C1. Okay. Another thing, you have to find out the power factor. The power factor formula I'm writing here. The power factor formula is what? It will be omega. It will be omega C1 R1. Okay, it is the power factor formula. And if you say permittivity, I will tell you in the next class. So if I have written the equation like this, then why I have written this, you have to understand. Okay, from this particular picture, this type of equation has come. This is a sharing bridge. Don't forget, sharing bridge equations are different. Arrangements are different. Okay, so keep this up to today. In my next class, I will discuss this problem more. And wait, let me share the QR code once if anybody has left out. Okay, so if you have seen the screen, seen the equations, then you will be able to find out R1, C1. Okay, if I see the equations, how it is coming, that is important. How the equation is coming, that you need to check it out. Give the QR code if anybody has left out. Then I will show you the board again.
Ma'am, value of C1 equals to 380 microfarad.
एक मिनट बताते हैं रुको. कितना है तुम्हारा वैल्यू ऑफ C1? बोलो.
384 microfarad.
No. R1, how much R1 is coming? That you tell me first, because yes, how much R1 is coming?
1.3 ohm.
1.23, not 3. If you have done some mistaken calculation, it will be somehow 1.23. See, कुछ तो गड़बड़ किया है. some calculation mistakes you have done.